William's background is in spacecraft dynamics and systems with an emphasis on small satellites, including the behaviour of spacecraft swarms around asteroids. He's currently the CEO of HEO Robotics.
Thanks so much, Kimberly. Great to be here, guys, especially based at UNSW. Our company is just headquartered at the building across the way there, a few levels below AXA. Yeah, we work out of the AXA lab as well. We're developing a partnership with Professor Dubster here and using some of the great resources that they've developed here on campus. So, High Earth Orbit Robotics, we were initially developed as a asteroid prospecting company. But what we found is that the business case is still a little bit immature there. And after having some great conversations with people who operate large satellites in geostationary orbit, as well as defense, we found that there is a huge problem in geostationary in particular. And I'll just draw your attention to the four screens that we have here. So they're time sequential. So the furthest to your left is what we see of geostationary satellites from Earth at the moment. We just see a large white blob. Now, sometimes those satellites explode. So last year there were two such events, and one of them was fortunately in such a position that it could be caught using a ground-based telescope. So we had the explosion that you see in the second panel. The explosion is showing two plumes that we see in the third panel there. And then post-explosion, we see that there are a few small pieces of debris coming off, but that will be very difficult to track in future time. So this does happen on orbit, and at HEO Robotics, what we'd love to do is be able to have a look at the environment around geostationary assets. So have a look for space debris that does occur in this orbit, and also potentially have a look at the health of these satellites. So try and understand what's happening on these satellites before a rapid, unscheduled disassembly occurs. Cool. So this particular incident was it was an Indonesian spacecraft, led to a really catastrophic event in the streets of Jakarta. 17,000 ATMs went down that were all using data from this satellite. And there was about $109 million Australian lost due to the incident, written down on their report, annual report. And it was only the fifth satellite lost in the 2015-2017 timeframe. Yeah, so all those 5 satellites accounted for around $515 million loss of assets, and a whole bunch of lost service years as well. So what we see is that there's about a 2-year time frame from project beginning to project deployment in terms of geostationary assets. So that's a lot of lost time that I'm sure these operators would have loved to have seen kept. So what we'd love to do is have a situation where we'd be able to take more high resolution images of satellites. So this is the Dragon capsule from SpaceX, and this is a view from the International Space Station. We don't believe that we'll be able to get high-res images like this in the near term, but what we want to do is get between that blob and this high resolution, so we'd be able to start understanding what's going on. And we're also looking to be the first nanosatellite, commercial nanosatellite, to high Earth orbit. So we initially thought we'd be the first commercial satellite to pass low Earth orbit, but unfortunately there was a contender that beat us this year. In March, there was a DARPA mission with a commercial nanosatellite on board. Unfortunately, they're not allowed to talk about it much, but hey, I just let the cat out of the bag for you. And what we think is that our CubeSats, so we're looking at around a 6U form factor, will be essentially the security camera for assets in geostationary orbit. So at the moment there's a solar exclusion period for Earth-based and also low Earth orbit-based satellites looking at geostationary orbit, and that's just due to glare from the sun. And from high Earth orbit and above, we'd be able to look down on what's happening and understand what's happening 24/7. So essentially, like other billion-dollar assets that we have here on Earth, where we have a whole bunch of security cameras around them, we'd be able to roll back the tape and understand exactly what occurred and when. So just giving you guys a scale of where geostationary orbit is, I'm sure you think about it conceptually and mathematically. But what we have here is 5 slides, each of which is about 10,000 kilometers across, emanating from the center of the Earth here. We're just going to quickly pass through this. So low Earth orbit, 100 to 1,000 kilometers above the Earth, where the majority of SATs are currently. And then we've got nothing for another 10,000 kilometers or so. And we've got the MEO belt, so this is largely positioning satellites. A whole bunch of radiation in this area. And then a whole nother area of nothing. And finally, geostationary. And this is where the real value is in the satellite fleet. So this is where all the multi-$100 million to billion-dollar satellites sit. And there's around 450 of them active in geostationary orbit at the moment. So one of here robotics orbits, we're looking at several orbit types at the moment, but the one that we're most confident in presenting here today is at Geo plus 500 kilometers. So it's sitting just above the Geo belt, and it's in the Geo graveyard orbit, which is a fun place to be. So this is actually the only semi-technical slide that we have here today. Pretty happy to be candid about what we're doing in the break after this. Not giving too much away on the presentation though. So it's a 6U form factor, as I said earlier. We're dealing with a 80 millimeter aperture telescope. So because we're getting so close to geostationary orbit, we don't need the large apertures that you need from Earth or from low Earth orbit based assets to get the same resolution up in geostationary. We're working with a company, Odyssey, who are doing a great job in telecommunications. And we're looking at a few different bands, but we've got a Ka band here, but still not decided on that. For positioning, we're working with Andrew Dempster's team and producing an agreement there to work on weak GNSS positioning, and we're applying for another grant to progress that research there. And radiation mitigation, we've been working with Data 61, also based here on campus, and trying to understand how we could use their software-based solution to mitigate for flipped bits, or SEUs as we more commonly know them. One other thing that's super necessary about being up here in high Earth orbit is thrusting capabilities. So we're working with a couple of different companies, none of them Australian-based, unfortunately, and we're looking at using ion thrust. So just another quick look at that, excuse me, Geo plus 500 kilometer orbit. So instead of looking down from Earth, so looking at the nighttime of Earth and understanding what's in Geo using large telescopes, or from LEO in fact, we're looking down from high Earth orbit, meaning we can understand what's happening during the daytime. So just talking about the journey about how we got here. So as I said earlier, we were initially an asteroid prospecting company. And just a little bit of a story on that. We see around between 50 and 60 asteroids coming closer to the moon every single year, coming right close to us through Earth orbit. And what I found in my PhD research was that it's possible to do flyby missions of a fair few of these asteroids without ever leaving Earth orbit. And as some of you are probably aware, once you leave Earth orbit, you're taking at least half a year to get to an asteroid, and usually several years to investigate an asteroid. And that's where a lot of your costs are brought into the operation. So I think in the longer term, there is a business case to understand more about what's on asteroids as they pass super close to Earth. And I know there are some other interested parties around Australia. So really grateful for all your support there, and yeah, let's work more on this in the future. And just having a look there at the flyby incept, so you'd sit in a here-style orbit, and then you just fly out just a little way to where an asteroid would incept your orbital plane. So just giving you guys, this is one of those really ugly slides, but I put it in all my presentations, so yeah, sorry about that, but not sorry. Yeah, so just showing there's been a real momentum about our company in the last 6 months in particular. So we've gone through the Founder 10X program here at UNSW. And as part of that program, Tim was saying yesterday, I went to San Francisco once with the entire cohort, and then I was actually invited back. And we've had a few talks with several large companies in the US. One that I can speak about was Odyssey, a communications provider. Some that I can't speak about yet, but we're producing deals with those companies now. And hopefully I'll be able to give you guys some more details in the next month or so. But yeah, we've had a real momentum building behind us. And this is where we are right now. So as you can see there, we're in our seed raise right now, which is a great time. Lots of fun, lots of meetings with people. And we're working towards our first launch in late 2019. And we're also working with Defense. They're helping us through the Defense Innovation Hub grant process, which is really fantastic. Great customer if you guys have something that really responds to one of their needs. And just a quick look at our team. So as you can see in the middle down below, Tim's actually one of our advisors, hence wearing our shirts. Great guy to have spruiking your company. And we've got a great bunch of advisors behind us, as well as myself. And we've actually got our CTO, Haranya, in the audience, and I'm going to get him to stand up. Sorry, buddy. So feel free to ask Haranya a whole bunch, yeah, wave to him, a whole bunch of questions during the next break as well, and we'd be happy to answer as far as we can. And thanks so much.
Does anyone have a quick question that they would like to ask before we dash out? Okay, otherwise, please speak to Will or any of our other session speakers during the break. Thank you very much. Thank you.